Continuing on then from our selection for a belt-driven fan, we've selected this BC317. So that looks okay, so I'm going to go next. And we have some default thicknesses for the casing here. I'll go next again. Noise information, we can select silencers here if we need to. I'll go next again. The motor size by default will be a 4-pole for belt driven, or when we say any speed, Centrix assumes it is belt drive. We've also got the option here for direct drive variable speed, which I'll cover another time. So let's go next. So we need margins. You'll notice that the motor size is a 37 kilowatt. So we do need reasonable margins over the impeller power shown on the fan curve. Because we have belt drive losses, bearing losses, and we need some tolerance to allow for fabrication of this impeller, which may mean the actual power absorbed could be slightly higher. So this screen tells us the stresses and we have no warnings. We can go next. We can select the outlet orientation here. I might like to select, say, 135 as required by the customer. It's going to be a ducted inlet and it's going to be a belt drive, and I will use the arrangement 1, which is the motor on the channel base. So I'll apply that first and then click next. We've got some default pedestal materials, so I'll go next. Centrix will design the shaft. If we don't see any warnings, the shaft design is okay. We might decide we'd like to step down the end of the shaft. I didn't look too closely at the impeller, but let's draw the inlet assembly to scale to see how it looks. So this is using a taper lock bush, which can be bought in from other suppliers that specialize in welding hubs. So that looks fine to me, so I'll go next again. Now this shows the position of the motor. We can then draw that to scale just to see how it looks. And that looks okay to me. It's got a top terminal box, so that shouldn't be an issue. We'll close that and close that. Now, if the Centrix does not select the actual pulleys and belts, that's best done by the supplier of the belts and pulleys, or you can use the Fenner selector on the website, and then you can adjust the centers here. You can type in new centers and you can calculate either a new gap. For example, if I wanted to calculate a new gap here, I can type in, let's say, 1250 and click calculate, and you'll see this gap is now needed to be 273. We can also do a similar thing, change the gap and the centers and calculate the installation and take up. The installation being the amount you move the motor to put on the belts, and then the take up is how much tension you can apply to those belts. So they've got to be within a good range. If they're not, then Centrix will show a red warning. So let's go next. We've got some options here that we can go through. Let's go next. We've got some pricing here and some hours for various things. We'll say apply, and we're left here. This is the end of the common program between quotes and, let's say, detail drawings. So if we're doing a quote, we can go to the quote side. If we're doing the drawings, we'd probably get this from one of the salespeople, and we could go straight to the drawings section. Let's go to the quote section. We notice that we don't have a pricing for the electric motor, so we could type it in here. Any value will do for me for now, and we'll recalculate. We can make some of these things optional if we want to, like could be an optional motor and slide rails, because the customer may want to supply those. And then we can recalculate, which shows the sell price here and the margins. And then we can do a quote detail. So we'll generate a new quote, say OK, and there is our quote detail, which can be edited in this rich text editor. And then we can print it out. Alright, so let's just go back. And then we can also do a quick GA drawing here as well, which is to scale. And we got an access door. So I'll put the access door here. Looks like a good spot for it. So I'll do one click there, another click there for the text, and then right click to finish. And there's our drawing to scale. And we can save as a DWG, or we can just print it out.